The Cretaceous period, the last period in the Mesozoic era, had a diversity of birds. These included the extinct Enantiornithine birds, or opposite birds, which were the most common, most diverse, most widespread birds in the Cretaceous period, which could range in size from that of a sparrow to that of a vulture. There were also birds more closely related to modern birds, the primitive ornithurine birds, which retained a number of primitive traits. Some had teeth, some had claws, and included both flying forms and flightless diving birds. 65 million years ago, however, when a meteorite struck the Yucatan Peninsula and caused perhaps the second worst extinction event of the past 500 million years, perhaps causing the extinctions of between 60 and 75% of all life. This devastated world ecosystems. It is thought that the wildfires which spread instantly in the aftermath of this event would have devastated much of the terrestrial ecosystems, and then the nuclear winter like blocking of sunlight due to the debris cloud which was kicked up as a result would have devastated them further. This certainly had an effect on birds. How many bird lineages survived this extinction event? Was it a small number of lineages and then the diversification of the modern groups occurred after the extinction? Or did a number of bird lineages evolve in the Cretaceous and survive this extinction event? If one were to begin by considering the Paleognathous birds, the most basal group of birds alive today, there are some sources of evidence which would cause one to argue that the diversification of bird lineages occurred in the Cretaceous period and that multiple lineages survived. One could use genetic analyses, which often place the roots of molecular family trees deep in the Cretaceous. The fact that flightless birds exist on a number of different southern continents have caused some to argue that these birds must have spread while the southern continents were still joined, or at least not as distantly separated. There have been some claims of Paleognathous birds found among the fossils of the Cretaceous period. These would argue for an older branching of this group within the Cretaceous. There are, however, different arguments which would argue for the opposite conclusion. One could argue that the genetic analyses are based on assumptions for the rate at which new mutations are inserted in lineages, and that these assumptions are less valid under conditions like the aftermath of a mass extinction in which lineages are rapidly diversifying, and so therefore these genetic analyses are overestimating the dates needed to separate the various branches. While the majority of these Paleognathous birds are flightless forms, the most primitive fossils and one group, the tinamous from South America, are a flying group, which suggests that perhaps flightlessness was not the original state, but rather evolved multiple times. And given that the oldest fossils were of flying birds like the tinamous known from North America, there is one possible fossil from South America. This suggests that it was flying birds which spread to the southern continents, perhaps from northern continents after the mass extinction. And so the evidence does not clearly indicate which of these two models is correct.